Dear students, once again I welcome you for the acids, bases and the salt chapter. In our previous class, we were discussing on common salt, sodium chloride, how sodium chloride is manufactured from the seawater by the method evaporation followed by purification, then its use. So like that in 10th class, there are some salts, their preparation we have to study. Those salts are common salt, sodium hydroxide, sodium carbonate, sodium bicarbonate, plaster of Paris and bleaching powder. Yesterday one salt is over. Now today we will start the second salt, that is sodium hydroxide. So welcome to the preparation part of the sodium hydroxide. Sodium hydroxide is also known as caustic soda. It is a common name. Okay. Or lye. Lye is the very old name given to the alkalis which is very strong. Okay. So today we use caustic soda or the sodium hydroxide, but still old name is in practice in some books. So lye is the one which is strong alkaline, strong basic. Sodium hydroxide comes in the form of pellets like a uh, like a bar shape or flakes like our corn flakes is there, no? You have seen like that in that shape, or a granules, small drops, and in terms of solution also in the market. So it is available in different forms in the market. Which form you want, that you can purchase it. Sodium hydroxide is a strong base because sodium and the potassium hydroxides are the best bases and the strong bases. Okay, and caustic in nature. Caustic means what? It corrode. It reacts with the skin. It gives the burning sensation to the skin like acids. Therefore, it is not touched with the bare hand. Use the gloves properly or the apron. So caustic means what? Burning sensation, or it corrodes the skin. That is the meaning of the caustic. Now we'll go further how it is prepared on a large scale. See, there are two words I told yesterday. One is preparation, other one is manufacture. Preparation we use for the small scale, whereas production or the manufacture for the large scale. So in industry, we go for the large scale preparation. Why? Because we require chemicals in our day-to-day life for our various requirements. So let us understand how sodium hydroxide is produced or manufactured in the industry, and using what? Using the sodium chloride. Using the sodium chloride, we prepare sodium hydroxide. So sodium chloride is a starting point, starting material or raw material for the preparation of the sodium hydroxide. How it is prepared? Let us see. This method is called as what? Chlor-alkali process. Chlor means why it is chlor? So here not only alkali, because sodium hydroxide is a soluble base, so it is called as alkali. So not only alkali is formed, along with alkali one more is formed, chlorine. So that's why it is called as the chlor-alkali process. Sodium hydroxide is obtained by the chlor-alkali process. In this chlor stands for chlorine and alkali stands for sodium hydroxide. That's why it is called chlor-alkali process, already I told. In a chlor-alkali process, electric current is passed through the brine. Brine is what? It is a sodium chloride solution in water. After passing the electric current through brine, sodium hydroxide solution is formed near cathode. In this process, chlorine gas is deposited at anode and hydrogen gas deposited at cathode. Here what happens, NaOH is put in the water. So NaOH in water, NaOH plus water, when you pass the current, both will undergo dissociation, ionization, NaOH into Na plus and OH minus. In the same way, water dissociates into H plus and the OH minus. And we know in the physics that anode is a positive electrode, cathode is a negative electrode. So positive electrode attracts the opposite charge and the cathode negative electrode attracts the positive ions. So accordingly, depend upon the charge on the electrode, opposite ions will flow. Okay, after flowing, anode is positive, so anode is attracting the minus ion. minus ions are Cl minus and the OH minus. Out of these two, okay, Cl will convert, not OH. Okay, why only Cl will convert? That will learn in the 11th class, depend upon the potentiality of the electrode. Okay, so OH will remain as it is. Now towards the one more electrode. What is that electrode? Cathode, negative. There are two positive ions. One is H plus, other one is Na plus. Out of two, which will convert? So it is H plus, because it is very small, very highly reactive. It will not stand, unstable. So H plus will convert into H, normal H, whereas Na plus will remain. There Cl minus will convert into Cl to gas. Here H minus will, H plus will convert into H and H to gas. Wow. What is left here in the container? Na plus left, OH minus left. They will react, they will combine and forms NaOH. So this is the process. Okay, right. See here. Yeah. So this is the anode, this is the cathode. Okay. So here near the cathode, H plus will convert into H2 gas, escapes. Near the anode, Cl minus will convert into Cl and escapes here. How Cl minus will convert into Cl? Cl minus means what? It is having more electrons. So it will give electron and becomes normal Cl atom and escapes. Okay. Now those electrons are taken by the H plus and becomes normal H and escapes here. So what left? Na left and OH left. They will react and use NaOH. Okay. So this is not a balanced equation. You please balance it. So 2 NaCl, 2 H2O gives 2 NaOH, H2 and the Cl2. This is the main equation. But what happens here inside, I already explained. So this is the what? You take inlet for the brine comes here, and these two are the electrodes. Okay, it is a membrane not to move unnecessarily the ions. It is called a barrier or obstacle. Then after the process over, whatever left is there, no, that waste is taken out from. This is called depleted brine, means waste brine. And what we want? We want NaOH, that is the taken from this tap. Okay, this is the method they use in the industry. Now use of see products. Sodium hydroxide. See, all these are uses in soap industry, detergent industry, paper industry for removing the color or acidic impurity, in making nylon fiber, okay, in degreasing the metals. Now chlorine, it is having antiseptic nature, so to treat the water free from germs, swimming pool, same reason, in making polyvinyl chloride pipes, PVC pipes, or in making disinfectants, chlorine tablets for the overhead tank supplied by the municipality, in making CFC, okay, chlorofluorocarbons in the refrigerator for the freons, okay. Now in making pesticide. Now uses of the what? Hydrogen for making fuel, best fuel, margarine like a dalda oil, in making fertilizers. What about the chlorine plus hydrogen? So together they use in the making hydrochloric acid. Okay, it is used in making some other chemicals. Okay, now these are used of chlorine plus sodium hydroxide combination for household activities. So these are what? All these are uses of the products of the reaction. Now after this, so we will see on video how it is prepared, right?
This lesson looks at what happens when brine undergoes electrolysis. You may need to look at our lesson What Happens in Electrolysis before going any further. The electrolysis of brine is an industrial process which is carried out on a large scale, but we can look at the process on a smaller scale in the laboratory. Brine is a saturated solution of sodium chloride. We don't want the electrodes to become part of this reaction, and so we use carbon electrodes. From the sodium chloride, we have positive sodium ions, Na+, and negative chloride ions, Cl-. And from the water, we have positive hydrogen ions, H+, and negative hydroxide ions, OH-. When the current flows, you will begin to see tiny bubbles of gas forming at each electrode. Both hydrogen and chlorine gas are formed. But can you work out which electrode produces which gas? Pause the video and see if you can work it out. The chlorine is formed at the anode, that's the positive electrode, and the hydrogen is formed at the cathode, that's the negative electrode. Did you get it right? Let's look at what's going on at each electrode. The anode is positive and attracts the negative chloride and hydroxide ions. The chloride ions give up their electrons to the anode and are oxidized to chlorine molecules. 2 ions need to be oxidized to make a diatomic chlorine molecule, and 2 free electrons are produced. The electrons are given up to the anode and the chlorine gas bubbles up to the surface of the cell. If you collected the gas from the anode in a test tube, then you would be able to see the pale green colour of the chlorine gas. It will turn damp blue litmus paper red, showing that it is acidic, and then it bleaches it. Well, what about the cathode? It is negatively charged and attracts the positive sodium and the hydrogen ions. The hydrogen ions each gain an electron from the electrode to form hydrogen atoms. Here's the equation. 2 hydrogen atoms then bond to form a diatomic hydrogen molecule, and that's the hydrogen gas given off. The gas here is colourless and can be collected in a test tube. The test to prove that it is hydrogen is done with a burning wooden splint, and you'll hear a familiar pop as the hydrogen burns. The ions left in the solution are the positive sodium ions and the negative hydroxide ions, which combine to form sodium hydroxide. Overall, the electrolysis of brine has produced hydrogen, chlorine and sodium hydroxide, and so we can write a summary equation. Concentrated sodium chloride solution plus water, when electrolyzed, gives sodium hydroxide solution, hydrogen gas and chlorine gas. These products are very useful, and the electrolysis of brine is done on a much larger industrial scale. Chlorine is used to kill bacteria, and it is soluble in water. If you've ever visited a public swimming pool, then you'll be familiar with the smell of chlorinated water, and it's also used to sterilise water in the mains water supply. What's more, chlorine is one of the main ingredients of bleach, which is used in a lot of cleaning products. But this is only scratching the tip of the iceberg, as chlorine is used to make dry cleaning ingredients, electrical insulators, building materials, refrigerator gases, weed killer, pesticides, antiseptic disinfectant. Some of the hydrogen and chlorine from the industrial process is combined to form hydrogen chloride gas. It's a rather unpleasant gas, but it dissolves in water to produce hydrochloric acid, which is a very useful acid. It too can be used for cleaning metal, but it is also used for producing chloride salts. Sodium hydroxide is another cleaning product, and the most common use for it in the home is for cleaning ovens and unblocking drains. That's a rather amazing collection of uses from our original brine.
Thank you guys for watching a small video on how the sodium hydroxide is prepared. Okay, this is selected from some website. I think it is very useful for you. For better clarification, please use the headphone so that you can hear sound very clearly. Thank you, my dear boys.